Good evening, everybody, and welcome to Summit County Nightscapes. First and foremost, I would like to thank the Summit County North Branch for inviting me down to do this presentation. Let's keep in mind that this is a fundraiser for the Friends of the Library, and that Janet has a donation bucket if you can spare some money so the library can get some books and needed supplies. Thank you for your support of Summit County Libraries. My name is Daniel McVeigh, and I am what is known as an astrophotographer. What is an astrophotographer? Well, this means that I enjoy taking photographs of many features of the night sky, including the Milky Way, the constellations, the moon, and other phenomena. Here is a self-portrait of me on the back of my Jeep, photographing the Milky Way in a photo inspired by a classic shot of Ansel Adams on his Woody station wagon. Tonight we will talk about astrophotography, mythology, and backyard astronomy, in a family-oriented presentation in hopes that everybody takes something home. Before we begin, I want to point out that I'm a photographer first and foremost, and this is the area I consider my expertise. Astronomy is my hobby. I'm neither a scientist nor an expert on folklore and mythology. Tonight I will be sharing my night sky photographs from mostly around Summit County. Included are some screen captures from Equinox 6 software, which are being used with permission. There are also a few images from Google Earth and NASA, which are in the public domain. Yes, it's true that you can go online and download high-resolution images straight from NASA that you can use as screensavers and art around your house. Let me give you a little information on my background, because it plays a role in my photography. I grew up just outside of Philadelphia in a suburban town in New Jersey. Philadelphia is located in the northeast section of the United States. It's one of many smaller cities comprising a megalopolis, or a giant city along the eastern seaboard. This megalopolis spans from Boston, Massachusetts, all the way to Atlanta, Georgia. Within this giant metropolitan area, it's very hard to see the stars due to all the light pollution. When I was a young student, a teacher once said that there are so many stars in the sky you cannot count them all. As a juvenile not knowing much about the night sky outside of my own experience, I was willing to take that challenge. To me, there were only the brightest constellations and a lot of dead space. As a child, I was fascinated by astronomy and space travel, so much so that upon graduating from the 5th grade, the elementary school gave me a science award simply for my passion. While in high school, I had a few black and white photography courses where I first developed my passion and learned composition as well as manual settings of a camera. But much of this information would be lost after a long lapse of not using a camera. I moved to Colorado about 13 years ago. The first night I arrived was moonless, and I almost couldn't find my way into the house where I was staying once the headlights of the car were off. I stared up into the sky, and I saw the glorious Milky Way with my own eyes, and it moved me. Around this time, I had bought my first digital camera, which was a simple 5-megapixel aim and shoot, no better than 90% of camera phones today, but was state-of-the-art for in my budget at the time. With this camera, I began renewing my interest in photography and taking landscape photos at a feverish rate. After about 4 years of this, I drove out to the summit of Boreas Pass to watch my first Colorado meteor shower. I so badly wanted to be able to record the show that I was witnessing. But my attempt failed with my fair, but inadequate for the job, equipment, and a definite lack of skill. A spark was born inside of me, however, and I decided it was time to buy a DSLR camera and relearn how to shoot manually. When I first started, I would hike out to various points along Boreas Pass and Breckenridge to start what I refer to as the trial and error process. Experimenting with camera settings in the field, I was learning a lot, but I was getting mixed results. When I moved to Silver Shekel, also in Breckenridge, I began to become more interested in the astronomy aspect than simply just photographing the night. With a gorgeous western view of the 10-mile range, I began to make simple observations of the cycles of the sun leading to and from the solstice, the cycles of the moon, and the motion of the heavens. I was learning to read the sky as a calendar and noticed that if you pay attention, you'll be able to predict events to come. At this point, I was producing images that I was really proud of and thought that maybe I could do something with my photos outside of sharing with friends and family. I enrolled in CMC Breckenridge because I wanted to learn how to prepare my images for print, and so took a Photoshop 1 class taught by Marie Orland. With the skills acquired in this class, I've been able to design and print several calendars, business cards, postcards, and all the graphic work on my website. This was an invaluable class to me in my pursuit of being a photographer. At the same time I took the Photoshop class, I also enrolled in an astronomy class at CMC taught by Siegfried Cutter, a former NASA physicist. I really thought that maybe we would learn about constellations and stars and, some basic things, but never did I realize the path he would take us down would be so detailed and helpful in my understanding of how the universe worked. My passion for astronomy was renewed, and I began to attempt to constantly quench my thirst. Nine years ago, I took my first night shot, and it's come a long way since. My photos have been seen on the internet at EarthSky, Space.com, Scientific American, Stellar Eyes, Filson Outdoor Clothing, the Summit County Voice, and more. They have been utilized by local businesses and publications, such as Mountain Town Magazine, the Summit Daily News, 303 Magazine, Summit Mountain Weddings, Colorado Life Magazine, and more. In person, my photos can be seen at the Colorado Mountain Art Gallery, across from the historic Hotel de Paris in Georgetown. One of the most common questions I get is, can you really see that many stars? And the answer is no. I struggle to see some of the more dim stars in well-recognized constellations, but that's just me. A still camera can be set to be more sensitive to light than our own eyes. The still camera has one more advantage. It records light over a period of time, when we see light more like a video camera as it hits our eyes. People often ask me how I acquire my images. The art of astrophotography, without going too far into detail, is not too different than landscape photography, but to the opposite side of the spectrum. There are three parts to a balanced exposure in photography: the amount of light allowed to enter the camera, which is the aperture; time the media can be exposed, which is the shutter speed; and media sensitivity, or film speed, what is indicated by the term ISO. A landscape photographer is almost always going to use time as a variable to balance the exposure, while aperture and ISO are the controls. They like to shoot through a tiny aperture, really just a pinhole for extreme depth of field, so that the near objects and the distant objects are all in an acceptable focus. They also use low sensitivity for the most crisp images, because at high sensitivity, the images become more grainy. Not as big of a problem as it was when film was the main archiving medium for photography, but still a problem today. A typical exposure in landscape photography for those who shoot manually is f22, 1/160th of a second, ISO 100. In astrophotography, it's flipped. Time is the control, and aperture and sensitivity become variables. Apertures are turned wide open, creating a narrow depth of field, and sensitivity is cranked high, creating more noisy images. This is a total nightmare from a landscape photographer's point of view. A typical exposure in astrophotography is f2.0, ISO 2000 for 30 seconds. All the images presented today are from a single exposure, except for star trail shots, which are several images. Hello? Except for star trail shots, which are several images that are layered on top of one another for one complete image. And panoramics, which are several side-by-side images stitched together to make a larger whole. I have not blended multiple exposures in the intent to extend the dynamic range of the camera, nor have I taken pieces of different photos and placed them together as a montage, or what many people would refer to as photoshopped. I enjoy the challenge of working within the dynamic confines of the camera, but I do want to leave the door open for any type of future experimentation. After learning operation of the camera, it all comes down to reading the sky. At a glance, the sky seems peacefully still, but upon closer inspection, we will notice that the stars and moon are in motion, just like our sun. These heavenly bodies only appear to be moving. It is our planet spinning on its axis that causes these bodies to move across the sky. The heavenly sky is a calendar, and it moves in predictable ways. Understanding this is critical to my photographs by imagining a picture and planning ahead to capture the image at the right time. People have been using the calendar in the sky for thousands of years. One of the first calendars that most cultures developed is the lunar calendar. This is simply a calendar that uses the phases of the moon to mark passing days. The moon takes 29.5 days to complete one cycle, but for convenience, we will call it 30 days. Each phase of the moon will appear in approximately the same place in the sky every month. If you missed a few days, it's not too hard to figure out where in the cycle you are based on the shape of the moon and its location in the sky at sunset or sunrise. I've broken down the cycle into two different phases in our diagram, waxing and waning. Waxing means getting brighter or the appearance of getting larger, and waning meaning becoming less illuminated or the appearance of getting smaller. Many cultures see a waxing moon as being young and a waning moon as being old. The first day of the lunar month varies between cultures, but was usually marked by a new moon which cannot be seen. The first visible phase is the waxing crescent moon. As we go through the cycle, notice how the light moves across the moon. A young waxing crescent will appear low as an illuminated thumbnail on the western horizon after sunset. I find that viewing the very first visible day of the crescent moon from the valley floor, here in Summit County, to be nearly impossible, as the moon is so low on the horizon that it is blocked by our mountains. But I continue to search for an angle. As the moon gets brighter or waxes towards a first quarter moon at about 7.5 days, it appears to have risen in the sky. The first quarter moon appears overhead at sunset when facing towards the south. Note that when we refer to the moon as a first quarter, we're referring to it being 25% of the way through the cycle. The first quarter moon appears to us as a half moon. The next major moon phase is the waxing gibbous, or what I refer to as a flat tire moon. It's become much brighter but not yet full. The waxing gibbous appears in the southeast after sunset. Here is the waxing gibbous with the bright planet Jupiter. And the full moon rises on the eastern horizon opposite sunset to complete the first half of our lunar cycle at about 15 days. This is the only phase of the moon that is visible all night long. Full moons have names, and most of the names that we Americans recognize come from different Native American cultures. Some common full moon names are listed here on our image. January is dubbed the full wolf moon. because this is the time of year that packs of hungry wolves howl outside of Indian villages. March sees the full worm moon, when the ground begins to thaw and earthworm casts appear, signaling the return of spring and the robin. July is the full buck moon, when the velvety antlers of buck deer begin to grow. November is the beaver moon, and the time of year that natives would set beaver traps in the swamps before the freeze of winter. Many of you have heard of the harvest moon, but did not see it on our list. That is because the harvest moon can be in September or October, as it is the full moon closest to the autumnal equinox, the midway point between the longest and shortest day of the year. I'm sure most of you have heard of the phrase once in a blue moon, or even use it to describe an event, to describe a rare event. But where does this expression come from? A blue moon is the second full moon in one of our Gregorian calendar months. In order for there to be a blue moon, the first full moon of the month must be on the first couple days of the said month. In July 2015, we will see the full buck moon on July 1st and the blue moon on July 31st. The waning phase, or second half of our lunar cycle, starts with the full moon setting in the west at sunrise. The second half of our lunar cycle is a mirror image of the first half. During the waxing phase, we talked about the location of the moon at sunset while getting brighter. During the waning phase, we talk about the location of the moon at sunrise. So here we have the full moon setting at sunrise to start the second half of our lunar cycle. Notice the red alpenglow in the 10-mile range at peak 3. Alpenglow is a phenomenon that happens just before sunrise or after sunset, when low-angled, indirect sunlight is bent or refracted by the atmosphere. As you may have guessed, our next phase is the waning gibbous. Remember, waning meaning less light or the appearance of getting smaller. Here is the waning gibbous moon set near peak T of the Gore range. At about 22 and a half days, we see the third quarter moon, or also called the last quarter moon, overhead while facing south at sunrise. And the last major phase before returning to our new moon is the waning crescent. The waning crescent appears in the east, just before sunrise. Here is the crescent moon with the planet Venus. Finally, we return to the new moon, which cannot be seen. As mentioned, the moon completes its cycle about every 30 days. The ancient Egyptians, who were trying to know when the annual flooding of their life-giving river, the Nile, were to happen, realized that their lunar calendar wasn't working. The Egyptians, using the lunar calendar, had 12 30-day months. We all know 12 times 30 is 360. We also know that there are 365 days in a year. But the Egyptians, they did not. They began to notice a different celestial event at the time when the Nile would flood. The rising of Sirius, just before the sun in the east. When they went back to figure out what went wrong with their calendar, they realized that their lunar calendar was 5 days short, and they developed what is now described as a lunisolar calendar, where they added 5 days at the end of the year, dedicated to the sky goddess, Nuth. The Hebrew, Buddhist, and Hindu calendars are examples of lunisolar calendars still in use today. A purely lunar calendar is still in use in Saudi Arabia, and it requires much updating. Many other Muslim countries recognize the solar calendar for day-to-day activities and the lunar calendar for religious purposes. The moon is the brightest object of the night sky, followed by the planets Venus, then Jupiter. The word planet is of Greek influence, derived from a word meaning wanderer. Unlike our constellations, the planets are not fixed in the sky, but appear in ever-changing places in the heavens as they move through their own orbit of the sun. The Greeks did not understand, as we do today, that these wanderers were not stars at all, but other worlds orbiting one star, the sun. For thousands of years, people tried to calculate the orbit of the planets. But it wasn't until Sir Isaac Newton, believed by many to be the greatest scientist ever, published the Principia Mathematica in 1687, where not only does he describe planetary motion, he invents his own system of mathematics, called calculus, to do so. There are 5 planets that are visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. Venus, the brightest of all the planets, is seen only as an evening star or a morning star, and is never seen crossing the night sky. The ancient Greeks saw this as 2 different stars, Hesperus, the evening star, and Phosphorus, the bringer of light, the morning star, until they eventually realized that what they were seeing was one star, and they named it Aphrodite, the Roman equivalent of Venus, the goddess of love and beauty. To the pre-Columbian Maya, Venus was the great star, and it would be used in planning for war and ceremony. The Maya devoted 26 pages of the Dresden Codex to Venus, covering a span of 37,960 days. They also understood the Venus cycle, in which the planet would return to the same position in the sky after 584 days. Venus can currently be seen in the west as an evening star. This photo is from early March. Jupiter is the Roman name we recognize for this planet, meaning the god of gods, and the Greek equivalent of Zeus. Jupiter is the second brightest planet in the night sky, but it is the largest planet in our solar system, more than 300 times the size of Earth. It is a gas giant. Some scientists believe it may be a failed star. As Galileo Galilei first noticed when he turned his telescope to the night sky, Jupiter looks like a beautiful marble from Earth, with its massive storm, the giant red spot. This red spot has been present ever since that moment in 1610, 400 years ago. Jupiter can currently be seen in the southeast after sunset. Saturn, one of the most recognizable planets as seen by telescope, is seen as a ringless but bright orb in our night sky. This is a scene from April 2014, but Saturn was the father of Jupiter. Saturn had a habit of eating his children to prevent them from growing up and taking his power. Jupiter was the 6th child. When Saturn decided it was time to eat Jupiter, his mother fooled Saturn by giving him a stone to swallow instead. Jupiter would grow up and usurp Saturn's power. Saturn, one of the most recognizable planets as seen by telescope, is seen as a ringless but bright orb in our night sky. This is a scene from April 2014, but Saturn is currently visible in the night sky, rising in the east before midnight. Mars, or Ares to the Greeks, was the god of war and the son of Jupiter. Seen as an especially important god to the Roman war machine, Mars was given its own month on the Julian calendar, March, which kicked off the season for military campaigning. Some suggest that the planet Mars was associated with war for its bloody color. Mars in modern day is the red planet and appears as a reddish-orange bright orb in the night sky. Mars has been currently seen below Venus in the west after sunset, but is getting more difficult to see as it gets lower on the horizon. Every night, a pageant of Greek mythology circles overhead. Perseus flies to the rescue of Andromeda. Orion faces the charge of the snorting bull. Bootes herds the bears around the pole, and the ship of the Argonauts sails in search of the Golden Fleece. These legends, along with many others, are depicted in the star patterns that astronomers call constellations. Ian Ridpath in the book Star Tales. The constellation system used in Western culture today is based off a book by the Greek scientist Ptolemy called the Almagest, which was published around 150 AD, where he describes 48 constellations. Ptolemy did not invent these constellations. As early as 700 BC, ancient Greek writers such as Homer and Hesiod described the Pleiades, Orion, and the Great Bear. So where did they come from? In order to understand this, we oddly enough need to move about 350 years into the future from Homer and Hesiod. Eudoxus was a scientist and a mathematician who published several great works. Among them was the Mirror, or Entropon, and Appearances, or Phenomena, at around 350 BC, where he describes the 44 original constellations. Eudoxus had learned the constellations from the Egyptians and provided it to the Greeks about 200 years before Ptolemy's Almagest. Unfortunately, these books were lost over time. Fortunately, some of the information from the Mirror and Appearances was recorded in a surviving poem by another Greek figure, Aratus, about 100 years later, whose work was also entitled Phenomena. So, we're still wondering who charted the first sky, because we know that many of the described constellations were around since at least 700 BC. And by looking at the constellations described by Aratus and the ones not described, we can tell that the original observer was south of Greece, but north of Egypt. And by noting the polar star described by Aratus, we can put an approximate date on the original observation at about 2000 BC, or over 4,000 years ago. Most scientists today agree that the original chart came from the ancient Sumerians and was passed down to several ancient cultures. Around the 8th century AD, the Center for Astronomy moved from Alexandria, Egypt, where Ptolemy had written the Almagest, to Baghdad, where his book was translated into Arabic. In 964, Al-Sufi published his own version of the book entitled Book of the Fixed Stars, where he introduced many star names, which is why we see so many Arabic star names in our so-called Greek constellations. To make a long story short, over the years, new constellations would be added, including the constellations not seen from the Northern Hemisphere. By 1922, the International Astronomical Union, the IAU, adopted a list of our 88 internationally recognized constellations. In 1930, Eugene Delport published his book, Delimitation of Scientific Constellations, for the IAU. This book defines the constellations not as star patterns, but as defined areas in the sky, much like countries on a map. Polaris, the name of the current North Star, sits very close to the celestial pole. The celestial pole is an imaginary straight line that the Earth spins on. If you look at a globe, the points where the stand attaches to the sphere are the access points. Did you all hear me say current North Star? Well, what that means is that the North Star changes over a very long period of time due to wobble, much like a spinning top in the Earth's rotation, called precession. Scientists were able to date the earliest known description of the night sky to the Sumerians by learning about the polar star known today as Thuban, which was described by our friend Aratus nearly 2,000 years after the observation was recorded. Surprisingly, in the night sky that belonged to Aratus and Eudoxus, there was not a North Star. It's strange that they would not see a problem with this, but good for us in dating the original constellations. Polaris, our current North Star, won't be closest to the celestial axis until 2102. By 4000 AD, we will have a new pole star, Eris. The North Star can only be seen from the northern hemisphere. If you were on a boat in the Arctic Sea, it would appear overhead, and all the stars would spin around like light from a giant disco ball. If you sailed your boat south towards the equator, Polaris would appear lower on the horizon until it went out of view. If you were in your boat and found yourself in a terrible storm and lost your direction, you could use the North Star at night to return to course. And by measuring how many degrees above the horizon that the North Star lies, sailors can figure out their latitude. In Silverthorne, the North Star is at 39.6 degrees, and so our latitude is 39.6. If you stared at the North Star for a while and sped up time, you may get a bit dizzy. This is because of the effect of the circumpolar stars that spin endlessly around Polaris and never set in the northern latitudes of the northern hemisphere. One group of stars you may recognize that spin endlessly is the Big Dipper. The Dipper is not its own constellation, it's part of the constellation Ursa Major, the Bear. Scientists refer to recognizable subsets of stars such as this as an asterism. Other asterisms include the Little Dipper, the Teapot in Sagittarius, the Winter Circle, and the Winter Triangle. Did you know that you can use the Big Dipper to find the North Star? By using the two stars Merope and Dubhe, you can make a line to Polaris. Well, kinda. Many people with a sharp eye may realize that this is not a perfect alignment, but it's very close. Another famous circumpolar constellation is Cassiopeia. It is easily recognized by its zigzag shape, or W. And where Cassiopeia is, Andromeda is not far away. According to mythology, Cassiopeia was the wife of King Cepheus and the mother of Andromeda. Cassiopeia was in love with her own appearance. She boasted of her beauty and that of her daughter, Andromeda. As punishment, Poseidon sent a monster to cause death and destruction to their country. In order to appease the monster, the king and queen chained their beautiful daughter to the seawall as a sacrifice. Without a moment to spare, Perseus arrives on scene with the snake-haired head of Medusa, which was so ugly it turned the monster to stone, and one of the most famous Greek mythologies ever recorded. The Navajo see it differently, with the Big Dipper as Nahokos Bika, or the male revolving one, and who is the ideal provider and protector. Cassiopeia is seen as Nahokos Biad, the female revolving one, and shows strength, motherhood, and regeneration. In between lies Polaris, which is seen as Nahokos Biquo, the central fire, and provides warmth, light, peace, and ceremonial healing. You can use Cassiopeia to find the Andromeda Galaxy by using the brightest star in the constellation, the Alpha Star, known as Shadar, the heart of the Queen, as a pointer star. The Andromeda Galaxy is the only galaxy outside of our own that we can see with the naked eye from the northern hemisphere. It's very faint, and I struggle to see it. If you would like a real good look at our cosmic neighbor, I recommend binoculars, or better yet, a telescope. Andromeda, or M31, is not the only galaxy in our local group that can be seen from the northern hemisphere with magnification, such as a telescope. If we look real close at this image, we can see M32, a dwarf galaxy believed to be orbiting Andromeda. Here is an image from NASA that gives us a better idea of what we are seeing. Also showcased in this image is M33, the Triangulum Galaxy. It's also very faint, but if we look over here, we see something that looks like a little smudge. This is the Triangulum Galaxy, and here is a photo that NASA has provided. Another type of calendar is a horizon calendar. Knowing when certain constellations rise or set can indicate seasons. Our most recognizable star patterns, Orion, Sirius, Orion, Taurus, and the Pleiades, rising in the east, let us know that winter is approaching in the northern hemisphere. Who was Orion according to mythology? According to the ancient Sumerians who developed the constellations, Orion was Gilgamesh. Upon returning from a great battle with the monster Humbaba, guardian of the cedar forest, Gilgamesh is approached by Ishtar, the goddess of both love and war. Ishtar is so impressed with Gilgamesh's accomplishment that she immediately asks him to marry her. Gilgamesh lashes out on Ishtar for how easy she falls in and out of love, and how she is particularly nasty to her ex-lovers. Angered by Gilgamesh's comments, Ishtar runs to her father, the sky god, Anu, and asks if they can unleash the bull of heaven onto Gilgamesh, who thwarted her advances. Anu, reminding us how important the night sky was as a calendar, warns that if they unleash the bull too soon, the people will go through a great famine without having the proper food storage. But out comes the bull, and after a great fight, Gilgamesh slays the bull of heaven. Interestingly enough, in the Epic of Gilgamesh, our hero has a long-term goal of immortality, to which he is denied. I find this to be fitting, as we people of the world don't see Gilgamesh but Orion. There are no surviving records that suggest the Greeks ever even adopted a tale of Orion versus Taurus. In Greek mythology, Orion first appears to us in Homer's epic poem, the Odyssey, as the son of Poseidon. Orion was strong and handsome, and armed with a club made of solid bronze. The greatest human hunter that the world had ever seen. While visiting the Isle of Chios in one of his expeditions, Orion met and fell in love with Merope, the daughter of the king. In order to win Merope's hand in marriage, Orion was challenged by the king to rid the isle of all dangerous animals. Orion completed this challenge, but the king continued to make excuses as to why Orion and Merope could not wed. This infuriated Orion, and he began to act out, trying to gain possession of his maiden, Merope, by violence. In turn, this angered the king, who had Orion blinded while he was sleeping. Desperate to get his sight back, Orion spoke with an oracle. He learned that To regain his eyesight, he would have to travel east by following the sound of the Cyclops' hammer to the island of Lemnos, so that the rays from the rising sun could restore his vision. Along the way, Orion would encounter great adventures. In another one of Orion's great adventures, we find him out hunting when he happens into a sunlit glade where he finds the daughters of Atlas, a titan who held up the sky. Orion frightened the sisters in play, and they quickly fled from him. Orion was so enamored by their beauty that he chased the Pleiades, or seven sisters, across the face of the planet for several years. When Orion was finally closing in on his prey, Zeus, or Jupiter to the Romans, the god of gods, intervened and turned the sister into a flock of doves, where they flew into the heavens beyond the reach of their pursuer. So if we turn to our image, we get to meet the cast of our characters in our story: Orion, Jupiter, and the Pleiades. What we are witnessing is Orion in pursuit of the Pleiades, with Jupiter in between, as it was seen in the winter of 2013. Let's talk for a second about the two brightest stars in Orion, Rigel and Betelgeuse. Rigel is a blue supergiant star, the brightest star in the constellation, and the seventh brightest star in the heavens from our point of view. It is almost twice as hot as our sun, and 40,000 times brighter. Betelgeuse is a red supergiant, approaching the end of its life. Stars this massive do not go gently into the good night, but erupt into one of the greatest firework displays that the universe bears witness: a supernova. We know that Betelgeuse will supernova from our point. From our point of view, it could be today or in a million years. We don't know when, but when it does explode, it will brighten for several weeks to months, maybe even as bright as a full moon, and visible during the day. The name Betelgeuse has an interesting origin. In Al-Sufi's book, Orion is known as the giant, and Betelgeuse is labeled as Yad al-Halza, meaning hand of the giant. When medieval astronomers look back at Al-Sufi's book to translate into Latin, they confuse the Y with a similar in appearance Arabic B, and subbed the Latin G for the J, and came up with a different spelling, but similar in sound, Betelgeuse. There's one more point within Orion that I would like to touch upon, which is the Orion Nebula. The Orion Nebula is an enormous cloud of gas and dust. It is a stellar nursery, producing stars as young as 1 million years old, newborns to the universe. And no great hunter is complete without his dog, so over here to the left we see Sirius, the dog star and companion of Orion. Has anybody ever heard the term dog days of summer? Today, we usually associate this as being a period of misery and distress in the summer between July and August. But what this really means is that the dog star is rising with the sun. Sirius is the brightest star in the night sky and is part of a binary system, meaning that there are two stars orbiting each other. As mentioned earlier, Sirius was an important star to the ancient Egyptians, sometimes referred to as the Nile star or the star of Isis, and its rising in the morning was tied to the flooding of the Nile River. The Pleiades is not a constellation, but a star cluster located in the boundary of Taurus. The stars in this cluster are about 100 million years old. Most modern people who gaze at this cluster see 6 prominent stars instead of 7. So why the designation as the Seven Sisters? Mythology says at one point in antiquity, 7 stars were visible, and over time one disappeared. There seems to be some evidence for this, but many modern astronomers disagree. According to one Greek myth about the Pleiades, upon the destruction of the great city of Troy, Electra, an ancestress of the city, and one of the 7 sisters, was so saddened that she left her sisters. and was transformed into a comet to be a sign of doom to come. In the Americas, the Pleiades disappearing in the west during spring was a sign to plant corn, and when the cluster reappeared in the east during summer was a sign to stop planting. The Navajo saw the Pleiades as Dilye, or seed-like sparkles. Let's return to Orion for a second, because although he's a winter constellation, he's important to our discussion of the dominant summer constellation, Scorpius. Another story in mythology tells us that Orion boasted he would kill every animal on Earth. Fearing this, the gods sent an armored scorpion to attack Orion, which successfully stung and killed him, making them eternal enemies. This is why today you will never see Orion and Scorpius in the sky, because Zeus placed them in opposite quadrants. Some observers even suggest that as Orion chases the Pleiades across the Earth, Scorpius is in pursuit of Orion. The Navajo tell a much different story, where Orion is seen as the son-in-law, and parts of Scorpius as the mother-in-law. The story associated suggests that the relationship of son-in-law and mother-in-law should be that they never see each other, and that's why the pair are never seen in the sky at the same time. I asked a Navajo friend about this tradition if it was still alive today, and her only reply was, "I wish." So here we have the constellation Scorpius and our big summer event, the summer Milky Way. The stinger stars of Scorpius, Shala and Lasath, lie within our Milky Way band. Hawaiians tell the story of the bottom portion of Scorpius as a fishhook, which was used by the demigod, Maui, to pull the Hawaiian Islands from the ocean. Antares is the 16th brightest star in the sky and the feature star of Scorpius. It is known as the heart of the scorpion. And like Betelgeuse that we saw in Orion, Antares is a red supergiant that could supernova at any moment from our point of view. The word Antares is Greek for rivaling Mars. Perhaps to deceive, as it is the same general color as Mars and nearly as bright. Can you see all this green on the far side of the image? Well, this is not aurora, but a phenomenon known as air glow. Oxygen particles high in our atmosphere interact with sunlight during the day and become excited or ionized. At night, when the particles try to return to their normal state, they release microwave invisible light. Green air glow is about 60 miles high in our atmosphere, and red air glow, which is not pictured here, is from oxygen atoms higher than 60 miles. The effect is likened to placing a glow-in-the-dark sticker under a lamp for several minutes, then turning off the lamp to witness the light from the sticker. Air glow is not visible to observers on Earth, but it can be detected and recorded with camera gear. Air glow is visible from space. Here's a photograph taken of a sphere of air glow from the International Space Station. The summer Milky Way is an on-edge view of our galaxy. We often see images of the Milky Way from a third-person perspective, like the top of this frisbee. But these are simply artists' interpretations of what might be seen. We have not seen our Milky Way from outside the galaxy, but we do get to see it from within our galaxy. When I turn the frisbee so its edge faces you, this is the view of the galaxy that we see. In the winter, we look into the Orion arm of the Milky Way, our local neighborhood, and towards the outside of our disk. Many of the winter constellations appear so bright because we are looking at stars that are relatively close. In the summer, we look into the Sagittarius arm and towards the center of our galaxy. The Egyptians were the first to associate our galaxy with milk, believing that it was a pool of cow's milk, which they worshipped as a fertility cow goddess called Bat. Many Native American cultures refer to the on-edge view of our galaxy as a river or road, often for migration or for transit into another world. The Inca believed that the Milky Way is runoff from the Vilcanota River and ties heaven to earth. The river and Milky Way are said to be mirror images of one another. And the Milky Way was viewed as a path to the upper world for the souls of the deceased, and that dreams of the living were views into this world. Many cultures around the world have adopted the idea of the tree of life, which connects the underworld through the roots, the middle world with its trunk, and the heavens with its branches. The Maya went further, and they saw the Milky Way itself as the world tree, a celestial representation of their ceiba tree, and that star clouds were the place where all life began. Here on our diagram, we are looking towards the center of the Milky Way, and notice what is known as the galactic bulge. Visible light is blocked from large clouds. These cloudy bands to the outside are composed of stars. We actually cannot see the center of the Milky Way because visible light is blocked from large clouds of gas and dust in between. Astronomers today look towards our galactic center by detecting light outside of the visible spectrum, such as microwave and X-ray. Here is a shot of the James Clerk Maxwell Telescope on Mauna Kea in Hawaii, which studies the Milky Way in light of the sub-millimeter wavelength, or microwave. And this is the University of Hawaii telescope, and was the first telescope constructed on Mauna Kea. It observes the universe in visible and infrared light. The laser seen in this shot is coming from the Keck Observatory, which is studying the center of our galaxy, including the supermassive black hole. The soft orange glow is coming from the first quarter moonset. The Dark Rift, Great Rift, or even Dark River is a star factory in our galaxy. The newly formed stars are surrounded by so much dust that visible light cannot pass through, and so the areas appear vacant to our eyes. The Maya referred to this area as the road to the underworld, and emphasized its importance when their long count calendar ended on December 21st of 2012. It's true that December 21st is the winter solstice, but why end the calendar in what we know as the year 2012? The Maya understood precession, the wobble in the Earth's rotation that we talked about with the changing of the North Star. To an observer in the Yucatan, and through precession, on this day the sun was in line with the section of the Milky Way known to us as the Dark Rift, and to the Maya as the road home on the winter solstice. As you may know, this alignment could not be seen with the naked eye. There are some people who speculate that the long count calendar is based on the complete cycle of precession, but modern Maya experts disagree. Today we recognize the Milky Way as our host galaxy. Just as the moon orbits the Earth orbits the sun. Our sun, as part of the Orion arm, orbits the center of the Milky Way. A still more glorious dawn awaits. Not a sunrise, but a galaxy rise. A morning filled with 400 billion stars. The rising of the Milky Way. A quote by astrophysicist Carl Sagan. Everything we talked about up to this point have been common sights of the night sky. Now I'd like to share with you some not so common astronomical events. Supermoons, or what till recently were called perigee full moons, are labeled when the moon is full and it's at its closest point to Earth in its rotation. The name supermoon was coined by astrologer Richard Noel about 30 years ago, but was not used in mainstream culture till a few short years ago. Super full moons can be seen in 2015 during the months of August, September, and October. Lunar eclipses happen when the moon passes through the shadow of the Earth, which is a somewhat rare event. Many people mistakenly believe that the phases of our moon have to do with the shadow of the Earth. This is simply not true. The phases of the moon occur due to the angle of sunlight on the moon and have nothing to do with the shadow of the Earth. During a lunar eclipse, the moon takes on a reddish-orange tint. This is a phenomenon called earthshine. This means that sunlight is reflected off the surface of the Earth to the moon, and from the moon back to us. This phenomenon inspired the recent nickname of blood moon, which is tied to a 2013 book by John Hagee called 4 Blood Moons, where he talks of biblical prophecy with 4 successive lunar eclipses in 2014 and 2015, with the third eclipse happening in a few short days on April 4th. A lunar eclipse always precedes or follows a total solar eclipse by about 2 weeks. Solar eclipses happen when the moon passes in front of the sun. This event can be calculated and predicted as most events in the sky. The Maya had an excellent understanding of the sky and could predict events such as solar eclipses. During the final long count year on the Mayan calendar, or what we recognize as the year 2012, the Maya accurately predicted a solar eclipse, and one of the most rare events in our solar system. The transit of Venus, where the planet appears as a dot on the face of the sun. The transit of Venus comes in pairs, separated by a few years, and was most recently seen in June of both 2004 and 2012. The next pair of transits will be in December of 2117 and 2125. Aurora is not typically seen from the latitude that Summit County sits on, but it's not impossible to see. Occasionally, a large solar flare will prompt scientists to put out an aurora notice when it's possible to see the show at more southern latitudes. I've gone out on these nights, and I've come home empty-handed. The night this image was shot, there was no aurora notification. In the field, I noticed strange light pollution, unlike any other I had seen, that was being recorded by the camera, but unseen to me. I made a few images and moved on to why I was originally in the location. After getting home and reviewing the photos, I began to wonder if what I was seeing was aurora, so I asked a few friends in the scientific community, and one suggested sending the image to NOAA, Geomagnetic Storms in Boulder. When I sent the image in, they responded that although there was no aurora going off in Colorado, there was aurora happening in Canada at the time and direction of my photo. They said that what I was seeing was the tops. They said what I could be seeing was the tops of these aurora. Comets, along with eclipses, are seen by an overwhelming amount of cultures as a warning sign of bad things to come. We know now that comets are balls of ice and rock left over from the formation of our solar system. Many scientists believe that all the water on Earth may be able to be traced back to an onslaught of comet impacts on the young Earth during the early stages of our solar system. The tail of a comet is only visible when the ball of ice and rock comes close to the sun. When a comet is far away from the sun, it does not display a tail. And finally, I would like to close where we started with meteor showers. Each annual meteor shower has a name which reflects its radiant point, or the area from which all the meteors seem to be moving away. For the Orionids meteor shower, the radiant point is the constellation Orion. The Leonids meteor shower is the constellation Leo, and so on. Annual meteor showers happen when the Earth passes through the path of a comet, and leftover debris from the tail enters the atmosphere, providing a spectacular nighttime show as the debris burns up in the atmosphere. 2015 looks to be a great year for meteor showers. My two favorite shows are the Perseids and the Geminids meteor shower. The Perseids will peak under a new moon on August 12th and 13th, and the Geminids will peak in December 13th and 14th under a young crescent moon. Thank you everybody for coming out. I hope you enjoyed Summit County Nightscapes. And thank you to Janet, Friends of the Library, and the North Branch. Please remember that Janet has a donation jar at the back of the room to help the library gain needed supplies. Thank you for listening. Does anybody have any questions? Finally, I'd like to make a quick plug that although I'm totally sold out of Summit County calendars, I know that both the Frisco Lodge and the Next Page bookstore have a few remaining copies if anybody is interested. Thanks for coming out.